Robotics is a very impressive field that is rapidly progressing. Maybe one day we'll have automated manufacturing facilities, and due to Deepmind, we're one step closer to that future. The new AI boasts never-before-seen skills that will revolutionize the field of robotics. Deepmind is well known for its groundbreaking developments in artificial intelligence and technology. Today, we will learn about its newest innovation, RoboCat, an amazing AI model that has revolutionized the industry with its transformational powers. Robots quickly become part of our everyday lives, but are often only programmed to perform specific tasks well. While harnessing recent advances in AI could lead to robots that could help in many more ways, progress in building general-purpose robots is partly slower because of the time needed to collect real-world data training. There is one major drawback to robots. Most are hardwired to excel at one or few specialized jobs. If you ordered it to do anything different, it would not comprehend. This is where AI can assist. Recent AI developments may enable robots to learn more effectively and quickly. We may now have general-purpose robots that can execute a range of activities rather than just one extremely well. And while this seems simple on paper, it is far more difficult in practice. The reason for this is training. Training AI requires a large amount of data, and gathering that data for robots may be a time-consuming and challenging process, which is one of the reasons why progress in developing general-purpose robots is slow. We're coming closer to having all-purpose robots. Deepmind published a paper on June 20th, 2023, discussing its latest innovation, a self-improving AI agent for robotics called RoboCat. When RoboCat learns to do a job, it develops its collection of training data after receiving some initial training. It will create more data to develop, providing a larger data pool to learn from. This is a huge step forward in the field of AI and robotics. A lot of training data is not required for RoboCat to learn how to pick up blocks. Google bought the London-based firm in 2014, and their investment in Deepmind appears to be paying off. The RoboCat AI is the world's first model that can learn and solve various tasks with varying aims. It can perform and adapt to various jobs by utilizing real-world robots. The majority of Deepmind's demos have also included robotic arms. Scientists have been studying methods to develop robots that can accomplish several tasks at once and blend linguistic models with practical skills of a robot helper before anybody looked into how robots can multitask at scale, and RoboCat is the first agent to do this successfully. RoboCat is based on gato in Spanish for cat, a multimodal model that can process words, pictures, and actions in simulated and physical contexts. Google integrated Gato's architecture with a large training dataset of picture sequences and robot arm motions doing hundreds of jobs. After this first round of training, Google launched RoboCat into a self-improvement training cycle with a set of previously unseen tasks. The learning of each new task followed 5 steps. Collect 100 to 1,000 demonstrations of a new task or robot using a robotic arm controlled by a human. Fine-tune RoboCat on this new task arm, creating a specialized spin-off agent. The spin-off agent practices on this new task arm an average of 10,000 times, generating more training data. Incorporate the demonstration data and self-generated data into RoboCat's existing training dataset. Train a new version of RoboCat on the new training dataset. RoboCat is also extremely fast at learning compared to other cutting-edge models. It only takes 100 demos to comprehend a new task, implying that humans are not required to monitor this robot. During training, it increases its capability of becoming a general-purpose robot 100% of the time, while also speeding up robot research. RoboCat learns rapidly because it already has a big and diversified data collection. It uses this data set to fully comprehend the task demonstration in Google's blog article. They even shared a RoboCat demonstration, not just on one robot arm, but on a new one. Deepmind RoboCat achieved the astounding accomplishment of learning and completing 253 tasks across 4 unique types of robots throughout a series of studies. The robot successfully adapted its training to go from 2-fingered to a 3-fingered robot with twice the amount of controlled inputs. This demonstrates how intelligent this AI is, because even a human would struggle to use an entirely new limb if that level of bioengineering were possible today. Consider how long it takes people to learn how to walk. It takes years to master the balancing and physics of your own body, so it cannot be overstated how excellent this AI is at performing these complex tasks that may appear mundane to the typical person while altering its appendage. Because of this training, the most recent RoboCat is based on millions of trajectories from actual and simulated robotic arms and self-generated data. We collected vision-based data depicting the task RoboCat will be trained to accomplish using 4 distinct types of robots and many robotic arms. RoboCat guided this new arm's dexterity enough to pick up gear successfully 86% of the time, after seeing 1,000 human-controlled demos in hours. It could adjust to accomplish activities that required accuracy and knowledge, such as removing the proper fruit from a dish and completing a shape-matching problem with the same level of training. RoboCat features a virtuous training cycle, in which the more new tasks it learns, the better it becomes at learning new ones. After learning from 500 demos per task, the first iteration of RoboCat was only 36% effective on previously unknown challenges. However, the most recent RoboCat, which has trained on a wider range of activities, more than quadrupled the success rate on identical tasks. Advanced machine learning algorithms and neural networks analyze data, discovering patterns and extracting important insights. This iterative approach aids in developing knowledge models and representations that allow it to make accurate predictions, solve issues, and produce creative solutions. The model passes through a feedback loop to ensure ongoing improvement. This loop entails analyzing its performance and adding input from human interactions to fine-tune it. Its models fix any mistakes and improve decision-making processes. This cyclical feedback loop promotes a continuous improvement cycle that allows the organization to learn from its failures, adapt to new problems, and grow its capabilities over time. As RoboCat interacts with humans and faces different situations, he develops himself. It is constantly updating and improving its knowledge base. This continuous learning process helps the model keep current with the newest information. Trends and advances ensuring its knowledge remain relevant and correct. RoboCat is a foundation agent for robotic manipulation that revolutionizes how robots interact with and control items in their environment. The model can alter industries, such as manufacturing, logistics, healthcare, and others, due to its advanced skills in cutting-edge technology. Its success as a foundation agent is based on its capacity to comprehend and handle items with accuracy and skill, thanks to advanced sensors and sophisticated grouping mechanism. RoboCat can analyze an item's form, size, and texture to make precise judgments about how to manipulate them. This degree of awareness allows a robot to interact with items in a human-like manner, bringing up many applications. One of the most significant benefits is its adaptability and variety. Using machine learning and artificial intelligence algorithms, it can learn from its interactions and adjust its manipulation tactics to the individual needs of different items. This adaptability enables RoboCat to handle a wide range of goods with similar ease and accuracy, from delicate and fragile materials to big and bulky items. The model's robotic manipulation capabilities go beyond simple item manipulation. It can execute complicated activities like assembly, sorting, and packing, considerably increasing productivity and efficiency in sectors that rely on these operations by automating these procedures. RoboCat lowers human labor, decreases mistake risk, and boosts total operating speed. Furthermore, this isn't restricted to a single robot. It may act as a collaborative agent, collaborating with other robots and humans in a shared workspace. This collaborative method provides efficient and synchronized manipulation where robots can cooperate on tasks, exchange information, and achieve common goals. Human-robot collaboration results in a dynamic alliance that combines human creativity and problem-solving talents with the precision and efficiency of robotic manipulation. Deepmind has again produced another technological breakthrough with its capabilities driven by transformer-based AI and a self-improvement training cycle. RoboCat has cleared the door for more advanced self-driving techniques. As robots advance and push the boundaries of what is possible, the future promises enormous potential. If you like this video, please like it, subscribe for more thought-provoking stuff, and share it with your friends.